components of a reinforced concrete building. A reinforced concrete building is made up of elements which transfer the loads applied on it to the ground and maintain the structural integrity of the building. For this video, we are looking at a four-storied building having a podium and a basement. Hi guys, this is Structures Explained, and in this video we'll be talking about structural components of a reinforced concrete building. A reinforced concrete building is made up of elements which transfer the loads applied on it to the ground and maintain the structural integrity of the building. For this video, we are looking at a four-storied building having a podium and a basement. A structure can be majorly divided into two components, which is substructure and superstructure. The structure which is below ground is generally called as substructure and structure above ground is superstructure. Starting from the substructure, first we have is plain cement concrete, also termed as PCC. It is a low-strength mixture of cement, fine aggregates, usually sand, and coarse aggregates. The main purpose of PCC is to provide firm, rigid, non-porous, impervious, and leveled base for RC footings, ground beams, and slab on grade. After PCC, foundation is laid which takes load from the above and transfers it to the ground below. Various kinds of footing are used in accordance with loading, site conditions, soil properties, and design. In this 3D model, first we have isolated footings, then comes combined footings which holds two or more than two columns, then comes raft or mat footings, and finally strip footings which in this case is provided to basement walls. Isolated or combined footings can be connected by tie beams if required by design. These tie beams run from column to column having reinforcement similar to floor beams. Structures also use pile foundations with different number and arrangement of piles having a pile cap over it. Raft foundation can also be combined by piles below it or thickening below the column if required by design. Next we will see the retaining wall or basement wall. They are provided to retain soil from one side and they may or may not have columns resting above it or embedded in it. Retaining wall or basement wall may have strip footing which may or may not be eccentric as per the property limits. Such walls are also used for water tanks below the ground. Next we are looking at columns below the ground, also called as column neck, as their length is shorter. These columns are embedded in soil and require appropriate waterproofing over them. After that we take a look at ground beams which run from column to column and may have secondary beams also. These beams are protected by PCC and waterproofing. After ground beams comes slab on grade or SOG. As the name suggests, SOG is laid on the grade or ground after PCC or waterproofing. In this case, SOG acts as a basement slab. Generally, slab on grade is not connected to column beam framing and directly rests on well compacted ground below it. Next we are looking at podium with little decal of our channel. Podium is generally required for landscaping, internal vehicular movements like cars and bikes and even fire trucks in case of a fire. It may house ducts for ventilation to basement. Next we talk about is pits, manholes and trenches for drainage purposes. This component may be casted in concrete brickwork or may come as precast unit as per requirement. These elements also require PCC at bottom and proper waterproofing. Then comes concrete plinths or concrete pads. These elements support heavy machinery or equipment such as generators, water pumps, transformers and provide a firm base to them. Concrete pad can also be reinforced or unreinforced as per design requirement and can be casted on site or come in precast unit with the equipment. This ends our substructure and now we'll see superstructure members. First we see is columns which are vertical load bearing members on which beams and slabs rest. Columns transfer the gravity loads and lateral loads from wind and earthquake. Columns can exist in various shapes and sizes according to architectural and design requirements. They can be T-shaped, L-shaped, circular, rectangular or square-shaped. Next we discuss various types of walls present in superstructure. First comes shear wall. These walls are part of lateral load resisting systems which counter the wind force and earthquake forces. Shear walls are placed at appropriate locations of the building by design and they start right from the foundation of the building. A combination of shear walls connected rigidly with each other is called a core wall. The core wall generally encloses elevators, stairs, or utility services in them. Core walls are also part of lateral load resisting systems of a building. Lastly, under the walls category comes upstand wall, which are reinforced concrete wall, usually of lesser height and thickness and having one end free. These walls are generally present as parapet walls around openings and on the ground where some amount of retention is required. Next in superstructures comes floor beams. Floor beams take the load from the slab and transfer it to the columns, shear walls, and core walls. Beams are basically of two types. First is primary beams, which are directly connected to the columns or shear walls, and second type is secondary beams, which are connected to the primary beams and transfer load from slab to the primary beams. The beams which have one end free are called as cantilever beams. The beams which run on the perimeter of the building are called as spandrel beams. Next comes slabs. Slabs are horizontal surfaces which take the load on them and transfer it to the beams and columns. Slabs in superstructure are also called as suspended slabs as they are suspended in air and not rested on the ground, as in the case of slab on grade, which we discussed earlier. There are various types of slabs based on structural and load transfer mechanisms. Based on design, the slab can be broadly categorized into two types. First is framed system and second is flat slab system. In frame type arrangement, the slab rests on beams. These beams may be further divided into primary, secondary, and tertiary beams. In the building, we also have a ramp which connects the basement to the podium and take the vehicular traffic. Ramp is also part of slab system and supported by beams and columns. Second category is flat slab system, in which slab directly transfers load to the column having drops or without it. The drops above the column prevent the punching of the column into the slab and provide stiffness over that area. If the thickness of slab alone is enough to resist the shear, the drops can be removed. Flat slabs can also be accompanied by beams at required locations, such as perimeter of the building and around the openings. Last but not the least comes stairs, which can be casted at site or come in pre-cast panels. They can be of various types such as L-shaped, U-shaped, spiraled, curved, as per requirements. The stairs can be enclosed in a core wall like in this case or rest at columns and beams as per design. I would also like to mention openings as a part of structural components, as opening break the load path and extra care has to be taken while providing size of the openings and reinforcement around them. Openings are mainly governed by architectural or MEP requirements. That's it for this video guys. We have more videos lined up covering each topic in detail, so do subscribe the channel and hit the bell icon to get notified for new uploads. See you in the next one.
Do your team brainstorms seem like they go nowhere sometimes?
Monica.
Hello, engineers. Good evening. I hope I'm audible. Can someone just type a one in the chat box if you can hear me? Right. Thank you so much, Dennis, Marceline, Naya. Thank you so much. Yeah. Good evening once again. If you have fellow engineers that you know that are part of this training that have not yet joined us, feel free to. Hello, Joseph, are you trying to communicate? Joseph, are you trying to communicate something? You can say it.
Hello, good evening.
Yes, good evening.
Sorry, proceed. I mistakenly unmuted myself.
All right, Engineer Joseph, thank you so much. Good evening once again. I was still communicating that we are at 41. If you have fellow engineers that are part of us, you can text them that we are live so that they can join us. So I hope you've listened to the video and watched it. So I'm going to request you to feel how your day was. Yeah, we want to know whether you're fine. If you're not fine, we shall send prayers over to you. Two, we shared deliverable one. Update us whether you are able to submit deliverable one, because every deliverable we shall be building onto that. And number three, share your takeouts from the video we've just shared. Briefly, you can tell us what you know about the substructure, the superstructure, etc. So feel free to unmute and communicate to us. We shall have an interactive session before I call in Engineer Gatimo to take us through modeling the substructure and other elements that we are going to work on today. So, anyone, feel free to unmute. As always, an interaction before we dive into what we have for today. I'm going to be forced to
Hello.
ask. Oh, okay. Engineer Dens, go ahead.
Hey, good evening, everyone. I think I'll start by reporting that I wasn't able to submit the first assignment. My installation of software had some issues, which we have just resolved now with Wes. So I'll be able to do it, I think, tomorrow and submit together with what we'll have studied today. On the video, I think my takeoff is it's basically describing the elements of a reinforced concrete structure, just from the foundation elements like the footings, the column bases, and the neck columns, the beams, the slabs, and I think the parapet walls. So I think shear walls also, just basically elements in a RCC structure. Thank you.
Thank you so much, Engineer Dens. It's great that the software issues have been resolved. So yeah, that is the spirit. Every deliverable has to be submitted and delivered. Thank you so much, Engineer Dens, for sharing. Next. Since Engineer Joseph had, yes, please proceed.
Hi, my name is Natalie. Can you hear me?
Yes, you're very audible.
Okay. I'm currently in transit because I caught up with some traffic before I got home. However, this is my first time and I'd like to just I'll listen more to understand where you are and I can be onboarded and I'll take the weekend to catch up.
Engineer Natalie, I didn't get you very well, if you don't mind.
Okay. I'm saying I'm currently in transit. I'm in a car and this is my first time to join the class. So I'll do more listening to understand where we are as a class, and I can take the weekend to catch up.
Oh, all right. Why not? This is our second session. The first session was basically introduction to the software, the interface, and a few things. So why not? You'll be able to catch up. Someone else, feel free to unmute and share. Yeah, I'm going to request Engineer Joseph, who had unmuted earlier on, to feel free to unmute and share with us since you had earlier unmuted, if you don't mind. Engineer Owit Horace, I don't know if you want to communicate with us, but you're unmuted. If you want to share with us, you can proceed.
Okay, thank you. I'm Morris from Kenya. So I'm grateful for, at least it was an exciting opportunity or to have to do it. You know, you can see friends or colleagues doing it, and then to be able to personally, like the scaling, linking the PDF files. But sometimes, like my challenge was when I was doing the linking with the grid lines, when I was coping at the challenge of uh, I got stuck somewhere, but I realized no, I was using the wrong lines. Instead of pick lines, I was just using the line command. So I could not copy correctly. But my team captain has been helpful. So it's good to have a forum where we can share in case you get stuck and then you get help. So I'm grateful for that. And thank you for everyone. It's a good place. So thank you.
Thank you so much, Engineer Witt. Yes, that is actually all about engineering, problem solving. You face a challenge, find a way how to maneuver it all. That is why we created different deep tubes where you get to interact with different engineers that probably have passed the hurdle that you're facing. So you're able to share and interact. Yeah. And yeah, that is the spirit of engineering, problem solving, never giving up, no matter what challenge you're faced with, you never give up. You have to get the deliverable done. Yeah, thank you so much, engineer, for that spirit. And I'm so happy that when you face the challenge, you managed to solve it. Thank you so much. Engineer Hamisi shared something in the chat box. Mine is to request the trainer to first take us through the floor plan generation. I tried, but I could not see the auto generated plan, but the grids and levels. Yeah, okay. Through the first floor plan. All right, I think you might be slightly maybe ahead of us because whatever you see on each floor plan, you're going to be able to build it at the end of the training. You will have a fully designed floor plan with all the required beam dimensions and slab, whatever the slab could be, whether it's a ribbed slab or a solid slab. You'll be able to model that, then you'll still proceed and detail out all the reinforcement required for all the beams, the columns, the slabs, whether it is a solid slab or ribbed slab or whatever type of slab that we have. So you might be slightly maybe ahead of us because the entire floor plans will be generated by us by the end of this training. So you probably could just hold on a bit. Yeah. I'll take more PD participants. Feel free to unmute and share with us.
Good evening, everyone.
Good evening, Engineer Kansime.
My name is Kansime Charity. I was able to hand in the deliverables, but I think I'm still having a challenge with linking the card. So I think that's the main challenge I faced since yesterday. I've been undoing until I had to just give in so that I can be corrected. My team captain was able to reach out and try to guide me, but I think there is something I'm not getting right. Then about the video we have just watched, I think I just joined the meeting late. I found it coming to an end. But otherwise, I think the scaling was the best part for me. It was easier for me. I think that's it.
Thank you so much, Engineer Kansime. Worry not, we have 2 days of training and 1 day of feedback session, purely feedback session where we get to solve whatever challenges you faced. Actually, you get to solve them yourselves because if you're still able to share your screen, we shall guide you through as you yourself solve whatever challenge you faced. So worry not, we have you covered, worry not. Someone else to share. I think I will take 2 more people before I call upon Engineer Gatimo. So someone else?
Hello.
Engineer Tom, are you trying to communicate with us?
Hello, good evening.
Good evening, proceed.
Yeah, this is Tom calling from Uganda. Basically, I would also like to share my experience with the software. Being the first time to interact with the software, of course, clicking something so fast is not easy. I was able to do the links, that is the PDF and the card. However, due to commitments, I didn't have enough time to do the other, that is the grid and the levels, which I promise I think by tomorrow should be able to hand in. And then the other thing is, I don't know it is interactive with the captains. At what time in the night could we disturb them? Because on my side, I see that the only time I have for these interactive sessions. Then on the video, I think basically they're trying to show us the elements of the reinforced structure. Otherwise, so far so good. Thank you.
Thank you so much, Engineer Tom. Yes, you have to create time in whatever busy schedule you have to create time for yourself and learn something new. It's a pleasure that you acknowledge that whatever engagements we all have, I'm sure most of the people that are here, we all have workplaces or we have other people we report to, we have things to execute, but yes, we have to create time for our personal development. And it's a pleasure that we are all here, and indeed that is the goal. So yes, we have to fix time within our busy schedule and get things done. The time of interaction, so it depends. You communicate to your captain, because as we are all busy, I personally, I review deliverables starting from 11 p.m. Onwards. And when I probably wake up at 5, I also review deliverables. So you talk to your captain, worry not. We are all flexible and we are here to help one another. We learn and grow as a team. So just talk to your captain and just request him the convenient time to probably share whatever challenge you're facing, and it will be of hope to you. Thank you so much. Actually, I don't know, Ingrid Gatimo, are you set up?
I am settled. Am I audible?
Yes, you're audible. You can proceed.
Super. Thank you so much, Engineer Abraham, for hosting the session for us and for leading the interactive session. I'll also thank the participants for joining us tonight for another session in Revit, and also for at least trying to work on the first milestone that we shared on Wednesday. I know that one, I hope that one would be easy. And if you are facing any challenges, please ensure you contact your captain for any assistance so that you can be able to move forward with the rest of us. Okay. So I was listening in the background, and I got to at least hear a few challenges that some of you faced. And I'm going to start with trying to address one of them. And if it helps you, well and good. If it doesn't solve your challenges 100%, please reach out to your captain, and they will help you address those specific challenges that you may be facing. Okay, so I will share my screen. I'll share my screen, and once you can see my screen, please type a 1. Let me know that my screen is visible. Type a 1 if you can see my screen. Super. Then I will ask all participants to ensure they are muted unless you want to communicate with us. Please ensure you are muted because we are going to record this session and we are going to share it with you. So if you keep probably interrupting the session, it reduces the quality of the recording. So we are going to start. And the first thing that I'm going to do is to address a challenge. I hope I got to understand it correctly. So someone was asking how they get to produce all the structural plans. So this is one from one of my participants in my deep cube, and I think you may be facing the same challenge. So you can see if this is what you have. Ideally, what you should have is you should have all the structural plans, such as this one. for each level that we created. So we had a top of foundation, the ground floor, then from the first floor to the fifth floor, the roof and the parapet floor. Okay. So if you are unable to go past this point where you only have the default structural plans that come with Revit, this is how you get to add the rest. All you need to do is go to the view tab. And then once you go to the view tab, you go to plan views and select structural plan. And then once you go to structural plan, all these levels that you created are going to be here. Okay. So what you need to do is just select all of them, select all of them, select all of them, and then click on OK. But before you do that, please ensure this check mark is on. Please ensure that you have this check mark so that you do not create duplicated existing views. So once this is checked and you've selected all of them, just click on OK. And you're going to have all your floors here. Then you can zoom in to ensure that the grids have been placed correctly, and you should be good to go. So what you can do to ensure that the grids have been placed correctly, just go to the elevation views. You're going to probably have some of these issues. What you can do is you can select one of the floors, one of the levels, and extend it beyond the other grids, okay? Then do the same in the north view. Just have a look, zoom into where it is, and then select these levels, and then extend them to ensure they cross all the grids, okay? Then after you do that, you should be good to go. And this ensures that all your floors have the necessary grids, okay? And then you can zoom out. Sometimes you may have created a few grids by mistake. So you can just zoom out and delete the unwanted grids and you'll be good to go. Okay, so that's how you easily do it. And with that, you are set to proceed to the next part. So I will only allow for one question by Dahir since you have your hand raised. So Dahir, please raise your question and then I'm going to proceed.
Okay, good evening, engineer. Okay, I don't want to stop you. I just want to make it clear. You know, during now the grid creation from the card that we have imported, existing grid. I don't know how you get rid of the existing grid, the level of the existing grid, because it is giving me a bit hard time, kindly.
I did not get that clearly. Please come up again.
Okay, I say once you import the card, there is the existing grid that already been labeled. So once we create our own grid, there is now the existing grids, the labels already of the existing grids. I don't know how we get rid of it. Maybe I don't know whether you get my question. If you didn't get, maybe I will do it another time. I will put it in a better way, so at least you can proceed with the presentation.
Let me try and understand that. Once we imported the PDF, the card file, what did we have?
We had the existing the existing grid, the level, just how I'm seeing now on the screen. Once we import the card, it has its existing grids, the levels, everything. So we use that grid to create our own grid.
Yes.
Yeah. So after we create our own grid, then the initial grid still exists.
Oh, I get you now. So we've created the additional grids in Revit, but still, the grids that we linked into our model in the CAD file still exist. Is that the issue?
Yeah, exactly.
Dahir? Okay, so that should not cause you any concern because later on, once we are done with the modeling, we are going to remove this CAD file and it is going to go away with its grid. Okay, so remember these grids that come with the CAD file, they are not in our model, they are just in the CAD file. Okay.
Okay.
So at this moment, you can just ignore them and you'll be good to go. Is that okay, engineer?
Yeah, perfectly.
Super. So I'm going to proceed to what we are going to do today. And in today's session, we are going to cover structural modeling for most of the superstructure members. That is the columns, shear walls, and then the beams. Hopefully, we'll get to do a few slabs, but if not, we are going to proceed in the next class. So I'm going to go to my PDF file, the one that we are using as a reference. And what I want us to do is to have a look at this PDF, okay? So what we have in this PDF shows us where the columns have been placed, where the different cross sections have been placed, okay? So you can see at grid B, we have a column 1 denoted as C1. Then we have some column 2s denoted as C2. And then we have column 3s, I think they are here. We have the column 3s at this point here. And then we also have some column 4s. Okay, so these columns are different in terms of the number of rebar required, how they have been detailed, as well as the cross-section details. So you can see, for example, for column 1, it is a section of 200 by 500 mm. And then the column 2 is a section of 300 by 500 mm. The column 3 is a section of 300 by 300 mm. And the column 4 is the 400 by 400 mm. So this is what I want us to do for today. So what you're going to be doing is, we know the cross sections, the values are here, and then we know where they have been placed. Sorry, we know where they have been placed. So we can, for example, read through this project. You can see where the column 1s have been placed. The grid numbering may have been done differently by this participant, but I believe that's a non-issue because we know how our structure looks and we have probably the better grid system at the moment. Okay, so we know where the specific columns have been placed, and what you're going to be doing is you're going to be referring to this PDF to model our columns. All right, so I'm going to go to do that. So this is what we are going to do. We are going to go to our Revit software and we are going to begin our structural modeling journey. You can do this in any floor plan. You can do this in any floor plan, but I recommend starting in the ground floor or the top of foundation. So let's start in the ground floor for this one. But you're going to notice that the CAD file is not available in the ground floor. So what you are going to do is you're going to move that CAD file from the first floor to the ground floor. Okay, and that is going to be really easy to do. All you need to do is go to your first floor. Okay, and then once you come here, just select the CAD file, place your cursor somewhere here, and you're going to see these rectangle that has been highlighted. Left click on it, and then after you left click on it, go to the properties panel, and in the work plane, just select ground floor, and it's going to be moved to the ground floor once you click on apply. So if you go to the ground floor, you can now visualize, you can now see it here. If you want to move it again, say to the 5th floor or the 7th floor, or to any floor of your choosing, you only need to select the CAD file, go to the properties, and then under constraints, work plane, click on the drop down and select the floor of your choice. So just for demonstration, I could choose the 4th floor. And if we now open our 4th floor, you can now see the CAD file. Okay. So I'll repeat that a final time. So to move the CAD file between levels, all you need to do is select the CAD file and then click on the level that you want to choose and then select it. Then I wanted to also reiterate or probably take this opportunity to explain that you can import different or multiple CAD files into your software. So if you're working on a project that has different or alternating floor plans at different levels. Say your second floor is different to your first floor, your 4th floor is different to your 3rd floor, rather consequent floors. You can be able to import those CAD files and then assign them to the specific levels. I hope you remember during the importation process where we were letting it go to the first floor. So at the same point, if you have your plans already created, or if you have your levels already created, you can be able to just click on the drop down and get to select the level that you need. All right, so enough with that. Now we are going to start modeling. And the beauty of working with Revit is that everything exists as a family, okay? So unlike AutoCAD or other detailing software where you probably work with 2D lines, and then you just use annotations to give them meaning. Say you just draw two lines somewhere, and then you are going to provide annotation to say these two lines represent a beam of say 200 by 450 mm. This rectangle represents the cross section of a 200 by 500 column. And like that, here we are going to be using live members that we can make changes to, that we can edit, and they store a lot of information. Okay, they can host the rebar in 3D as well, and they also store information with regards to where those particular members are in the structure, the material that is used to create them, as well as the levels where those particular members are. Okay, you could also modify the properties if you're working with a quantity surveyor so that you can have a cost estimate for each material. But for today, let's focus on the modeling part. So to model a structural column, all you need to do is go to the structural tab. Remember what we said last time, the structural tab is going to be our main home for this training. So most of the things that we're going to be doing, we're going to be going to the structural tab first. Then we are going to start with creating a column. So you go to structural tab and then left click on column. Then after you do this, you're going to go into the column creation tools, and you will notice that my contextual ribbon has already changed. So from the top, you can see some of the tools that are pretty familiar. You can see the cut and join, and also this first part at least looks a lot familiar to what we have had before. But this second part here, you can load a family. Remember, we said everything in Revit exists as a family. So be it a beam, be it a column, be it the annotations and the grid themselves, they are all families. Then next we have the vertical columns and the slanted columns. And then in the second option, we have the option to model columns at multiple columns. So if you were to choose this method, if you are working on a very, very simple structure where the columns are, or where the grids have been placed in a really, really easy way to model, you could just use that method and get to highlight all your grids. And if I zoom in, you're going to notice a column has been placed at every intersection between the grids. Okay. But since our structure is a bit more complicated than that, we're not going to use the placement. We are going to model the columns manually. So also, if you're working with a Revit architectural file, you can be able to place or actually replace architectural columns with structural columns. All right. So you can be able to do that. And then in the properties, this one shows us the type of the type of column we are modeling. So at the moment, you can see we are working with a universal beam column. This is a steel section, which we do not want to use for now. We are more interested in modeling an RC column. Okay. So to access the RC columns, all you need to do is click on this drop down, and you'll have the concrete rectangular families over here. Okay. So I will end that at that point, and then I'll repeat it just to reinforce it. So we are interested in modeling our columns. And to model our columns, our first destination will be the structural tab. And then at that point, you are going to scroll or select the column section over here. And then to choose the family that you want, be it as a steel column or any other type of family, you click on this drop down in the properties. I hope you can see it. These drop down in the properties, and then other families are going to appear. So you can see we have the 300 by 450 section, 450 by 600 section, and 600 by 750 millimeter section. So these families are not sufficient for us. They won't suffice because remember we are working with very, very specific sections. So those ones do not suffice. We even do not have one that represents our needs in Revit at the moment or by default. Okay, but the good thing is that this is they are easy to modify. And to modify a section, all you need to do is first select the family you need. So in the concrete rectangular column, you can select any family here. Okay, you can select any type here. So let's select the 300 by 450. And then after you select it, go to edit type so that you can create the section you need. So we are going to start with column 1. You are going to first duplicate these type properties. This is a family or a type family that you are going to be making changes to. And anytime you're going to be making changes to any family in Revit from now on, please ensure you always duplicate it so that you always have an original family to go back to. So this is what I want you to do. Once you open the type properties, you're going to click on duplicate, and then you're going to rename this. So we have column 1 here, and you're going to rename this column 1 200 by 500 mm. Okay, and then click on OK. Then after doing that, you've only changed the name. So you need to change the dimensions to match your needs. So our breadth will be 200 mm. Okay, so you enter 200, and our heights or our depth will be 500 mm. So you enter that, click on apply, and OK. And now you have a section of your choice. Okay, so I'm going to repeat that once more. So at this point, we've already created one column section, and we are interested in creating other sections that match our needs. Okay, so to do that, we are going to go to our PDF. You can see the next column section is a 300 by 500 mm section. So in Revit, you are going to go to structure, and then you're going to click on column, ensure you're working with the structural column. And then at this point, in the properties panel, click on this drop down, and you'll be able to select the concrete rectangular columns families over here. So you can select any of them here. You can select any of them here. So just select one of them. And then after you select it, go to edit type. And then here is where you make the changes you need. So the first thing that you're going to do is duplicate it and give it the name that you want. So let's call this 300 by 500 mm. And then click on OK. Then change the dimensions. The dimension will be 300 mm and the depth will be 500 mm. Yeah, and then after you do that, just click on apply and OK, and you're good to go. All right, so let's do the other one. So we are interested in column 3. So column 3 is going to be a 300 by 300 mm. It's a square column, but no worries. All you need to do is go to structural tab, column, and then click on this drop down over here. Then at this point, all you need to do now is select any of these sections, select any of them. So this time I could select the 600 by 750 mm, then go to edit type, you duplicate it, and then you name it. So let's name it column 3, 300 by 300 mm, and click on OK. Then after you do that, now change the dimensions to match your needs. So we have 300 mm by 300 mm. Then after you do that, just click on apply and OK, and you have the section created. So we can do the final one. Let me see what dimension it is. 400 by 400 section. So to do that, you go to the columns and then just click on this drop down. Select any section here. Click on edit type. The first thing that you're going to do is duplicate it. And then after you click on duplicate, you're going to be prompted to provide it with a name. So let's call this column 4, C4, and then 400, the dimensions 400 by 400, and then just enter the units. Then click on OK. Now change the dimensions 400 by 400 mm. Click on apply and OK. And now you are good to go. So we are going to start our modeling journey. And what I want us to do is to remember we are referring to this particular page to know where to place our column sections. So we can see between this first grid and the second one, we have column ones, and they are all oriented in this direction. Okay. So that's what I want us to do. we are going to go into Revit. And then once we are here, we are going to go to column. Then we are going to click on this drop down so that we can select the column section of our choice. So we are interested in the column 200 by 500 at this point. So select it, and then before you place it, I want you to have a look at these options bar over here. These ones are the settings that are going to be restraining your column, or they are going to constrain how your column has been placed. So you have the option to either rotate your column after placement or not. So for now, we're not going to check that. Then we are going to deal with that later on just to demonstrate it. And then we have this option here, depth or height. Okay, so these are the modeling options. You can place a column by either depth or height. So the difference between the two is that if you model a column by depth, it starts from the level you are in and it goes downwards. But if you model by height, it starts from the level you are in going upwards. So by depth, it means if you're in the ground floor, it will start from the ground floor going below the top of foundation. But if we model by height, it means our column will be modeled from the ground floor to go to the first floor. So I'm going to demonstrate both of them so that you can see how they behave. So for example, let's start with depth, and I'm going to place a column just arbitrarily at this point. And then I will go to my elevation views, and you can see how it has been created. It has been modeled from a ground floor going to the top of foundation. There is no problem with doing this, but I recommend working with height. It's a bit less confusing, especially when you are starting off. So I'll just delete this. And we'll go to our floor and place another column by height. So we go to column, and then we place it by height, and then just place it here. Then if you go to our view, you're going to notice that it is going to be modeled from the ground floor going to the first floor. Okay, so that's the key difference between modeling by height and by depth. Okay, so let's go to the second constraint. So column, we have the section we need. If you want to change the section, you just click on the drop down and get select the section you need from the ones you created. Okay, so we've seen how to model by height and by depth. Then the next one is the constraint. So where do you want your column to end? Do you want it to end at the first floor, at the second floor, at the third floor? You can be able to choose. So if you want your column to be placed from the ground floor to the fifth floor, all you need to do is select this column from the ground floor to fifth floor. And if you go to your east here, you're going to notice that your column has been modeled from the ground floor to the fifth floor. This is an ideal, and we normally don't do this. We advocate for you to model the columns floor by floor. That is ground floor to first floor, and then first floor to second floor, that way. Okay, so I'll delete this, and then we are going to model it the right way. So you're going to go to ground floor, and then we are going to click on column. And at this point, we are going to select the ensure it's a vertical column. First, ensure it's a vertical column, and then place it by height, and then restrain it to the next to the next level. So the next level is the first floor from the ground floor. And then after you do that, all you need to do is place your columns. Okay. So place them at the grid intersections. Look at what we have in this drawing. So the next one is at D. So you go to your software and you place it there. And you just left click to place it. Okay. So that's how easy it is to place your columns. I'm going to proceed to the rest. So what I'm doing is I'm going to the structural tab, column, and then you select the section you need. So for now, we are using the column 200 by 500. And then after you do that, ensure you are modeling by height and you're in the ground floor, going to the first floor. Then after you do that, after you have your settings set correctly, place them at the intersection of the grids in the areas you need them. So refer to the PDF to know where you need them. So we have this one here. So I'll just go to my software and place it at this section here. Then do the same here, okay? And proceed to do this for the rest. Let me see where that one has been placed. Okay, and proceed to do this for the rest of the structure. Okay, so you have that and you are good to go. So you can see you have now modeled your column ones properly. Okay, now let's do the column. Let's refer to the PDF. Now at this point we have a column 2 and we have a column 2 section over here. So how do we place them? You go to your Revit software, you go to column, and mind you, I want you to take note of the orientation. This one has been oriented in this direction. That is the longer span is in line with this grid here. So what you need to do is click on this drop down. Sorry, first go to structure, then column, then click on this drop down to select the section you need. So this is column 2, 300 by 500 mm. And then this time we are going to activate the rotate after placement so that the software assists us in rotating the columns after placing them. So you check this, check the checkbox, and then place your column. Then after you place it, you're going to be allowed to rotate your column. So just rotate it by 90 degrees and you're good to go. Okay. So you come to this section here where you have the grid intersecting, left click, and then just rotate your column. Okay. Rotate your column and place it in that manner. And you have your column 2 placed there. Then you can do the same. We have a column 2 here. So you just place it and you rotate it. This section, this grid here should also be a column 2. Our participants missed that, but this section here should be a column 2 as well. So once you come here, just place your column and then move your cursor out and then just rotate it to the other grid and you have it placed. So you can click on escape to continue. Yeah, just a moment. Okay, so let's proceed. We are going to go to the next part here. We have a column at this section. So what I need you to do is ensure you are referring to this PDF. Ensure you place all the columns you need. So what we need here, for example, I can see I messed up here, and this column should be at this section here. So if you make a mistake, as I did, don't panic. What you can do is just select the column and then go to move and move it by its center to this other intersection, and it's going to be moved. Okay, so now we need to place a column at this section here and at this section here, if I'm not wrong. Okay, at this section here. So let's do that. We are going to go to Revit. We have our column at this section. Let me see if I got that right. We have our column at this section here and the other one at this section here. So you go to structure, column. This time it's a column 3. So select the cross section you need and you place it there. And then you also place it here where you need it. Okay, so that's how you model your columns. Then just refer to the PDF. It now becomes a bit repetitive. So in this slide, we only need column 4s and column 3s. So we can do that. We go to Revit. Then we choose column, select the section you need, column 4, and then ensure you place it where it's required. So at this section there. Let me see. Then at this section here, the column 4 has been placed there. And then on this other end, it has been placed at a similar manner here and here. Then now let's model the column 3s. So we have these two here. So let's do that. We go to Revit and then we go to column. You select the cross section you need. So column 3 and you place it here and here where it is required and you're good to go. Okay, then if you want, you can visualize this in 3D. So to see your structure in 3D, all you need to do is go to the View tab and then click on this heart symbol or house symbol here. Left click on it. Let's change the visual style to shaded. And then with that, you can see your columns coming up really nicely. Okay, so you can see we've already done probably half of the structure. So I'm going to proceed and do the rest. So if you refer to the PDF, you're going to start in the upper end. You're going to notice now this section here between the first two grids also has column ones. So we are going to repeat the process. You go to structure, column, and then you select the cross section you need. So you need column 1, 200 by 500 mm. You left click on it. You ensure 1, you're modeling by height, and 2, it is constrained to the next floor. That is the first floor because you are in the ground floor. So then after that, you just place your columns, place them as they have been placed in the PDF file. Okay. Place them as they have been placed in the PDF file, and you should be good to go. So place them as they have been placed, and you should be good to go. So I just do that for all the areas where the column is supposed to be placed, and you should be good to go. Okay, so you can do this rather quickly, but I recommend you not rushing over this since it's your first time. And then over time, you're going to build up speed of working with this software. Okay, now let's proceed to create the column twos in this section here. So if I go to my PDF, I have a column 2 section over here, another one here, another one here, another one here, and another one here. So basically along 3, 4, all I have is column 2s. So I'm going to go to column. Remember the process of modeling the columns. You go to column, then at this section, you go to the properties tab and select the cross section you need. So we need column 2s. And then this time, because they are oriented in this direction, we check rotate. Then ensure you are modeling by height, and it is constrained to the first floor. So after you do that, just place it. Then after you place it, rotate it by 90 degrees. Okay. Then do the same here. Where does that end? Let me see. The next one should be here, where the others are. So the next one is here. So you just left click to place it where the grids intersect, and then you rotate it using your mouse, and then click on the other grid. Ideally, or alternatively, you can also type 90 and then enter, and Revit will model the rest for you. So we also have another one here. So you can left click at this grid intersection, move your cursor, and then type 90. Just type 90 on your keyboard, and your column will be placed there. Then do the same here. Type 90, and you are good to go. Then do the same here. So you place it and then rotate it by 90 degrees and press enter, and you should be good to go. Then after doing that, you've basically modeled the columns for that section. So we need to model the other columns in this section here. So a trick that you can use is you can always copy. So you can see these columns here, these column 4s are similar in this grid here. So we can copy these column 4s from this grid to this grid. So you can select this column 1, 2, 3, and 4, those 4 columns, and copy them here just to save time. So you can select them, left click on one, then press Control to select the other 2 columns. Okay. Then after you have that, click on copy, and you are good to go. So you just copy them to this other grid. So I'll repeat that. As you work with this software, at times you may need to look for alternatives to make your work a bit easier. So whenever you can be able to mirror objects or copy them, always copy them, provided they do not affect the quality or the accuracy of your work. So for instance, at this point, we can copy these columns from this grid here to this grid here, okay? So what you're going to do is you're going to select these 4 columns, 1, 2, 3, and 4. Please columns because they are not in this end or on this end. So to select these columns, you select this one, select it, then press Control to select the other columns that you need. Then after I do that, click on copy, then select the base point or the point along which you're moving the columns. So select the midpoint and then move it vertically or perpendicular. Seems I had some network issues and I had been logged out. So someone please tell me where you lost me. Someone please unmute. I am back. I can see people are already texting. I am back. I am back. Someone please inform me where you guys lost me.
Hey, engineer.
Hello. Someone please. Okay. Thank you,
I've
Horace.
lost. Yes, you have also lost you when you are copying the columns sections.
Okay, super. So am I now audible? Am I clearly audible? And someone please confirm that my screen is now visible. Okay, so I can see that my screen is visible. I'm going to redo that. Super. Thank you so much. So what I was saying was, when you're working with these softwares, you are always going to try and find ways to make your work a little bit easier and also to make you a bit faster. Okay. So in scenarios where you can replicate items, where you can copy items, please always do that because it's going to be faster than getting to model them by yourself. So what I did is from the PDF, we can see that these 4 columns are also placed in the same place on this other grid 8. Okay. So what I did is I placed my cursor on one of them, selected it, and then left click, pressed Control on my keyboard and proceeded to select the others. Okay. Then after doing that, I selected copy and then I left click at the midpoint so that I can move them by the midpoint. And then I just copied them to this intersection there, and I am good to go. Now you can see I have modeled all my columns appropriately. Okay, so that's how you model your columns in a really, really easy manner. And if you go to your 3D view, you can see in probably 20 minutes, you already have all the columns that you need. And the beauty of this now is that you do not have to redo the columns for each floor. We can copy columns from this level here to the other levels. Okay. And we are going to do that in just a moment. So to copy the columns, I recommend you working in one of the elevation views so that you can see how they are going to go about it. So we are going to copy the columns from the second floor up to the roof level, okay? And then for the parapet level, we have a different plan. So we're not going to copy columns since we don't need all of them for that level. So what you're going to do is you're going to go to one of the elevations. I'm going to go to north. And then at this point, I am going to highlight my columns from right to left. So I'm using right to left because I don't have to select the entire column. I just need to cross it. So what I will do is I will highlight everything along this path. Okay. I'll just left click on my cursor or left click on my mouse and then move my cursor from right to left. Okay. Then after I do that, you're going to notice Revit selects everything and you're going to see what has been highlighted. Anything that you cross is going to be selected. So you can see the grids have been selected and the columns have been selected as well. But we do not need to copy the grids. We only need to copy the columns. So what you're going to do is you're going to use the filter tool to filter out the items we don't need. So you go to filter and then you check none and check structural columns only. Then you click on apply and okay. Then after you do that, I want you to follow my cursor really closely. So what you're going to do, please follow my cursor. Once you've filtered out the grids, what you're going to do is you're going to go to the clipboard panel over here, and you have copy to clipboard in this section. Okay, copy to clipboard in this section. So left click on clipboard and then go to paste now. Now that you can paste, go to aligned selected levels and select the levels that you want to copy these two. So you select the second floor and don't select the first floor. So first select the second floor, then that floor, fourth floor, fifth floor, and the roof level. And then click on OK. And you're good to go. So you can see even in the 3D view, we have all the columns that are needed for our structure. Okay, so I'm going to repeat that one more time so that we can be able to grasp it really well. So I want to select all the columns in this flow. So I'm going to use the elevations since it's easier to select the columns in this view. So to select the columns, what I'm doing is I'm going to highlight from right to left. So by highlighting from right to left, Revit selects anything that my cursor crosses. So I'm going to just left click and then move my cursor from right to left. Okay, left click and then move your cursor from right to left. Then after you do that, you go to filter. And the reason you're going to filter is because the grids have been selected by that move. And we do not want to copy the grids as well. So our main interest is in copying the columns only. So we go to filter and then we are going to check none and select structural columns only. So we click on apply and okay. Now we have filtered out the grids. You can see they are no longer highlighted and only the columns are highlighted. So once you have this, what I want you to do is go to copy to clipboard. And after you go to copy to clipboard, go to clipboard and then click on copy to clipboard. So left click on this part and then go to paste, left click on paste and then aligned, paste this to aligned selected levels. So left click on aligned selected levels. And we are going to copy them from the second floor to the roof level. And the reason we are omitting the first floor is because as you copy columns, what Revit does is it copies them from the floor you have selected going downwards. So if we were to select the first floor, it means that Revit will model other columns from the first floor to the ground floor. And we already have columns here. So that will lead to us having double members at the same point, which is unideal or unwanted. So what you do is first select the second floor and then press Control, select third floor, fourth floor, fifth floor, and the roof floor. And then click on OK. And in a moment, you should have all the columns you need. Then the next thing will be to copy the columns for the top of foundation. So for this one, we are going to use a different workflow for that, just to give you a better understanding of the software. Okay, so we are going to copy them in the same way. We are going to select them in the same way. So we highlight them by left clicking our cursor or our mouse and moving it from right to left. Then after you do that, you click on filter and you check none. Then you check structural columns only. Then after you do this, you click on apply and okay. So by doing that, it means you are going to be selecting the columns only. So after you do that, now use the normal copy. Use the normal copy. So left click on copy, and then you can uncheck constraint so that you can move in the vertical plane. So click on this grid here where it intersects, and then move down and click on this grid there. And you're going to have your columns modeled for the foundation level. Then you can select them, go to the properties tab and ensure the base level is the top of foundation, TOF. The base offset, ensure it is 0. And the top level is the ground floor. And then click on apply and okay. And now you have all the columns that you need. Okay, so let's repeat that. We are going to undo what we have done. We are going to select these columns. Okay, then we filter out the grids. Okay, then after you do that, just copy them from this level and check constraint first, and then copy them from that level to this level there. And then select your columns, go to the properties tab, select only these columns that are below the ground level, ensure the top, the base level is top of foundation, and the base offset is 0. Then the top level is ground floor and the top offset is 0. Then click on apply and you're good to go. Now you have columns in this section there. All right, so that's how easily you can model the columns. So the next one is going to be modeling the shear walls of the lift core. All right, so I'm going to do that in the ground floor as well, just to make our work a bit easier. And you can see where our lift is. And this is the section where we are going to place our walls. All right, so this should be easy for us. It's going to follow the same principle for modeling, or the same principle we used in modeling the columns. So what we do is we go to structure, but this time we select wall. Ensure you selected the structural wall. Please ensure you select the structural wall and then select it. Then what you're going to do is you're going to create a family for our use. So what you're going to do is you're going to click on edit type, okay? Then go to duplicate, and then after duplicate, you're going to be prompted to give it a name. So we can give this lift core walls, okay? And then just click on OK. Then we will want to change the width. So if you want to use a different width, you go to edit over here, and then you click on the thickness and change it to the thickness you want. So we are going to use 250 and click on OK, apply and OK. And we are good to go. Okay, then after you do that, all you need to do now is model your walls. Sorry, before you model your walls, please remember the constraints that we had similarly to the column. Okay, first you want to model it by height. All right, model it by height and then constrain it to the second floor, to the following floor. So we are in the ground floor. The next floor should be the first floor. And then the location line, center line, that is the line that you're drawing, is going to be the center of your wall. If you are to choose a different section, say exterior, it means this line that you're moving your cursor along will be the exterior of your wall. But you are interested in this grid being the center line of our wall. So you're going to ensure the center line, the location line is wall center line. Then after you have that, just place your your wall there, place it on this other end as well, and do the same here. Okay, Okay, so if you had grids, it would be easier. I can see my friend here missed a few grids, but no worries. So if you had the grids, it would be easier to do this. But if you don't have them, you can just place them arbitrarily. And then once you have them, you can move them to where you need them. So I can move this one to that point there. And then I can select this one and move it to this point there. Okay. Then I can also select this one and move it to this point here. And after that, you have your walls created. So if you go to your 3D view, you can see your shear walls have been created over there. Okay. You can see your shear walls have been modeled over there. So what we want to do at this point is our lift core is not going to be closed. It's going to have a door opening. Our lift core is not going to be closed. It's going to have a door opening to allow uh, the building users to access the lift. Okay, so we need to create a door opening for this. So how do we do that? We go to the structural tab. Okay, and then in the structural tab, we are going to create a wall opening. Okay, so to create the opening, you go to the structural tab, and then you click on wall opening. So left click on wall opening. Then after you do that, you're going to notice your cursor changes to some last side or across if you'd like. Then after it changes to that, select the wall that you want to have an opening in. So it's this wall. So we are going to select it. Then after you select your wall, you're going to notice now next to the bottom right of that cross, you're going to have some polygon there. So what that means is now that you can create your opening. So all you need to do is highlight the area that you want your opening in. And this rectangle there represents our opening. Okay. So what we can do now is we can now ensure that this opening has been placed appropriately. So we can just place some dimensions there and get to see what we need here. So we want an opening of 1500 mm. So just select your opening, and then after that we can change this dimension so that the opening is 1500 mm. So we can move it by these grids here until it's 1500 or somewhere close to that. Okay, so we can have 400 on that end, and then ensure this end here is 400 as well. Okay, so I think this works. So I'll just delete that and we are good to go. So we have that opening created there. And if you go to your 3D view, you can now see the opening has been created in that particular section over there. Okay, I hope you can see the opening. Let me try and rotate it, and you have it there. Okay, so what I want you to do is I wanted us to look at this level here. This thickness above the opening, this is a structural member, and it is also going to be used to support our slab. So as we design or during your design phase, you are going to be able to determine this thickness and also the amount of reinforcement required. So for example, if you need a thickness of normally called the spandrel being about 600 mm, just select your opening. And then in the top offset, enter the depth that you want that spandrel to be. So if you need it as 600 mm, just enter -600 and press enter. Then apply, and it's now going to change. You have the depth that you require. Then after you do that, all you need to do now is select this opening. Let's do this in the plan view, so in the ground floor. All we need to do now is to select everything here. So for this one, highlight from left to right so that you select only the items that are in the lift core. So for this one, select from left to right. Okay, select from left to right, and ensure you cover everything in that lift core. This is after you have modeled the openings. So you select them from left to right. And then after you do that, you go to the clipboard as we did for the columns. You click on copy to clipboard, then paste and align to selected levels. Then as you did, please skip the first floor. Then copy this to the third floor, fourth floor, fifth floor, and the roof level. And then click on OK. And once you go to your 3D view, okay, so that did not go according to plan. So for this one, you have to copy them to the first floor as well. So if yours appears as mine, just go to modify, then go to paste, align to selected levels, and select first floor and copy your wall there. So you have your wall modeled there and you are good to go. Okay, you can see how easy that has been. So we are going to go to the first floor again, and we are going to copy these walls to where we need them. So I'm going to select the walls in this view. So you can select walls in one view and then copy them in a different view. So we can select the floors. So we are working in the ground floor. We can walls and then go to your elevation view and just copy them from the top parts to uncheck constraint. Copy them from the top parts to this bottom part, and you're good to go. So let me turn on shaded, and you can see our wall there. So after you have this, you can just highlight this section over here, select all those walls. So you can select them from right to left this time, so that you select all of them without necessarily needing to highlight everything. Then in the constraints, just as you did for the column, ensure the base constraint is top of foundation and the base offset is 0. And then the top constraint is the ground floor. Okay. And the top offset is 0. Then click on apply and OK. And you should be good to go. Now you have all the vertical members that you need for your structure. All right, so that's how easy it is to do. That's how easy it is to model in Revit. So the next thing that you're going to do is to model the beams. So I'm going to give you a 1 minute break just to absorb that. And then you're going to model the beams. Just a minute and then we continue. So we are going to proceed. Now that we have all our vertical members. Hello?
Can I ask a question?
Yes.
I was asking.
Yes.
You have all those. I've seen for the columns.
Yes.
You have assigned the depth and the breadth, the width and the
Yes.
breadth.
Yes.
So how when usually when you are analyzing for structures,
yes,
you wouldn't know the exact dimensions or the sizing of the beams of the columns.
Yeah. Yes.
So when you have modeled, can Revit analyze then resize or resize the column or depending with the loading?
Now you have to transfer the model to an analytical or a finite element software to do that, and then bring your model back to Revit.
Oh, okay.
Okay, so the purpose of doing this is if you are ready to design your structure, is because it's much easier to model in Revit as compared to other software. So you can model your 3D structures here, move them to your finite element analysis software of choice. And then once you have designed them there and gotten the member sizes and all the information you need, now you can transfer your model back to Revit for the next part in documentation and detailing.
Okay.
Okay, so thank you. So I'm going to proceed and you're going to model the beams. So what I'm going to do with the beams, I'm only going to model the beams for this lower end. And then you're going to follow the video. It's basically the same principle. And you're going to model the beams for the top end as you refer to the PDF that we have shared. Okay. Then, as you saw, it's going to follow the same workflow as we did for the columns. The first thing that you're going to do is create a cross section for them. So for the beams, we have 3 cross sections. We have a 200 by 800 beam. Then we have a 200 by 500 and the 200 by 450 beams. Okay. I think we also have some 200 by 600, but I'm not sure about that. But let's proceed. So to create the beams that you need, you go to Revit, and then this time you go to structure, and then you select beam. Then just as you did for the columns and the shear wall, you click on this drop down and select the member that you need. So we are working with the concrete member. So you select any of them. You can select any of them, and then you go to edit. Then the first thing, always duplicate the member, duplicate it, and then name it. So we could start with beam 1, being 200 by 450 and click on OK. Then after you do that, change the dimensions to 200, breadth to 200 and the height to 450. And then click on apply and OK, and you'll be good to go. So we'll repeat that. We want to create a second cross section. So you go to beam, then you click on this drop down, select any family in the concrete rectangular beams. So we can choose the 400 by 800 this time. Go to edit type. First thing, duplicate it. So 200, let's call this beam 2. 200 by 500 and then click on OK. Then change the breadth to 200 and the height to 500. And then after that, you do that, click on apply and OK. Okay. Then as you did for the columns as well, you just repeat that process until you have all the sections that you need. So for example, you could have a beam 3, 200 by 600 and then click on OK. Then change the height to 600 and you're good to go. So another shortcut that you can use here, once you click on apply, you don't need to go back and then come again through the structure route and then choose the section here. After you click apply, you can just click on duplicate it and then make all the changes here. Okay. So we can have the other one, 200 by 800, and then have that and then enter the height here, 800. Click on apply and OK, and you're good to go. Now you have all the families you need, so it's time to place them. So we are going to place them as we did the columns and the shear wall, following the beam layout shared in this PDF tool over here. So what you are going to do is you're going to refer to this section over here. You can zoom in on your PC. Sorry, please allow me to take some water. I have a sore throat, so just a moment. Okay, we can now proceed. We want to model the beams and we are going to be following this layout. So wherever the participant has labeled 200 by 800 mm, you're going to place that beam. Wherever she has modeled the 200 by 500 mm, you are going to place that 200 by 5. Sorry. Okay, so sorry for that. Let's proceed. Wherever she has placed a certain section, be it a 200 by 800, you're going to model that particular beam at that section. Okay, so we are going to start. We are going to do an example with this lower left section, and then I'm going to show you a faster way to go around it. Okay, so the first thing that you could do is, for example, at this section here, she has a 200 by 800 beam, then a 200 by 600 beam, and a 200 by 500 beam, and then 200 by 800, and then these sections are 200 by 500. Okay, so if you are new to the software, this is probably how you'd go about it. So you would probably start with the 200 by 800 beam section at this point. Okay. Let's change these. Before you start modeling the beams, let's do this first. Let's undo that. Let's start modeling the beams in the first floor. We are not going to use any beams in the ground floor. So what you're going to do is select the CAD file. So just place your cursor, move around it until you get to see this highlighted rectangle. Then after you do that, go to the properties, and then in the work plane, change this to the first floor, and then click on apply. Then now go to the first floor and start modeling your beams. Okay, so change your visual style to shaded so that you can see your structural members better. Change it to shaded so that you can see your beams better as you model them. So you're going to go to beam. Then for this section, she has a 200 by 800 mm beam. So I think this would be the way you would model it first. So first ensure the okay. Okay, we are good. For the beams, we don't need to make any changes in the properties panel. So we only need to place it. So just place it in that section there. And then you have the 200 by 800 beam there. So if for any reason you get that your beam has not been placed using the center by the center, or it has been placed one side of the grid, just select it, go to the properties, and then in the Y justification, ensure it is under center. Okay, so that ensures that just similar to what we had with the shear wall. It ensures that your beam has been placed along the center that line that you are drawing is actually the center of your beam. Okay, so we are going to go to beam again. This section we saw she modeled 200 by 600 beam. So we go to beam 200 by 600 and place it here. Then in this section here, you need a 200 by 500. So you need to change the cross section again and place it there. Then in this section, it's a 200 by 800. Then you change the section and model it there. Then again, this section changes in cross section. So you change the cross section in the properties tab. You go to 200 by 500, and then you model it there. So you click at this column there and at this column here. Then at this section, I'd recommend you start with these two, join them there, and then join them here. And then do the same here, join these two here, and these two here using the 200 by 500 beam. Okay, so I hope you can see that the changing from section to section usually takes a lot of time. It takes a lot of time. So what I recommend doing is, this is what I want you to do. Okay, this is just a tip to make you faster. You can model all the beams in one cross section. So we can say we are going to model all the beams here in one cross section. Okay, so we can say we are going to model all of them in the 200 by 500 beam. So we just place the beam wherever a beam has been placed in the floor plan that was shared with us. And we place it in such a manner, okay? Then this section also, we place another beam. Just wherever there's a beam in the PDF, you place your beam in the same cross section throughout, okay? You do that for all the beams. I promise you this will make you just a bit faster. So we do that for all the beams. Wherever there's a beam, you place them in this cross section. Then as you do this, I recommend you go through the drawing, get to identify which cross section is the mode, or which cross section has been used is the most, get to select the most common section to use for this modeling, so that you don't have to make a lot of changes later on. Okay, then let's do this there. And then after we do this, after we have all the beam sections that we need, we should be good to go. So at this point, what we have is we have beams in the same cross section. Some of them have not been modeled correctly, but most of them are actually matching what we have in the PDF file that we shared with you. Okay, so I could even add a few here just to make your work a bit easier. So I could just add some more beams here so that we can do this just to make your work a bit easier. So you just zoom in and ensure you place it by the center of the grids so that you're good to go. Okay. So zoom in and place it there as well. Then for this beam connection, the shear wall, please ensure you just click on the shear wall, and that you do not go towards through the entire shear wall. It's just like a column, so you just place it at that section. Then at this point, you're going to notice that there is an error. So it would be best if this shear wall actually moved up. So we can do that, or we can align this beam. We can move this beam to match these shear wall there. Okay, so you can choose what you want to do at this point. So if you model your shear wall, if you model your beam at this section, and the entire face does not go into the shear wall, what you can do is you can select this beam and then move it from that point here to this point there, so that it matches correctly. Okay, and then after you do that, just continue modeling these other beams. So we go to structure, beam, and continue with the section that we have been using. Okay, so we are going to move this one again. So you can choose to move the shear wall or the beam, but since this is a training exercise, you can just move the beam to make your life a bit easier. So then connect all the beams that you need. Connect all the beams that you need as shown in the PDF file, and have them wherever you need them. Okay. So please zoom in, ensure you are drawing the right line, and place them correctly. Okay. So I'm going to place one here and place another one here. Okay, so I think we are now set for this one, I think we have a beam. We have a beam here. So let me see. For this section here, we have a beam from this column and this column as well. So we go to Revit. We place a beam there and a beam here. And then after doing that, you connect those two beams to this section there and to this section there, and you're good to go. So you can see how modeling the beams in one cross section is faster than using different cross sections. Okay, but you cannot do this since after you design your structure, you are going to see that you need different that you're going to notice that you need different sections. Okay, you're going to notice that you need different sections. So what you can do at this point, after you have modeled all your beams in the same section, go to the PDF, identify the areas where you need a different section. So we can see this area here has a 200 by 800 beam. And then this area here has a 200 by 800 beam. So what you do, come to Revit, this section here, select it, and then this section here, select it as well. Then go to your properties, and then just select the beam that you want. Okay, and then after you do that, your beam changes to the section you need. All right, that makes it a bit easier. So you select the beams that you want to change. So if you look at the PDF, this section here has a 200 by 800 beam. This section here as well has a 200 by 800 beam. So you select them and you change them to the section you need. Okay. This section has a 200 by 600 beam. So you can change it to 200 by 600 and you're good to go. So this section has a 200 by 450 and you can see how easy that has been as compared to having to change the column section at every point. Okay, so the reason I deleted this one is because I accidentally modeled a shear wall instead of the beams. So we're just going to correct that. You're going to go to structure, beam, and then model it appropriately. Okay, then do that. So I hope you got how to change the section. Modeling the beam in the same cross section is much faster than you having to model the beams in different cross sections at every stance. Okay, and then after you have modeled all the beams, just go to your PDF file and look at them slowly. So you can have a look. Say if at this section you need a 200 by 600 beam, you just go to your software. At that section, select that particular beam and select the section that you need. Okay. And then after, if you do that, Revit does the rest for you. All you need to do is select it and you're good to go. So that's how easily you can model the beams. I am sorry, I'm having a bit of internet challenges tonight, but I'll have it resolved by the next session. So what you are going to do after you have modeled all the beams, I'm sharing my screen in a few. After you have modeled all the beams, what you're going to do is you're going to copy them to the other sections. Okay. So after you have modeled all the beams for the entire floor plan, following keenly on the PDF file that we shared with you, just go to your Revit software, and this is how you copy them. Highlight everything. You can just highlight everything. And then after you have them highlighted, you go to filter, and then you check none. So in Revit, beams are classified under structural framing. So anything that you see called structural framing is a beam. So I want you to check all checkboxes with structural framing. check all boxes with structural framing, and then click on apply, and then okay. So that will select all the beams in your floor plan. And then after you do that, just go to copy to clipboard as you did for the columns and the shear walls. Go to copy to clipboard, then paste, aligned to selected levels, and copy them to the floors you need. So we are already in the first floor. So we select second floor, third floor, fourth floor, fifth floor, and the roof level. And then after you do that, click on OK. And after Revit loads for a moment, you can go to your 3D view, and you're going to see that the beams have been copied throughout the entire structure. All right. So that's the exercise that you're going to be doing for today, and the deadline will be on Monday. I'm sorry for the internet challenges I've had, also for the pausing during the delivery, but I hope the recording will be good for you to model the other beams as well. So follow the recording as well as the short videos that I'm going to provide you with. They are going to assist you in completing your milestones. Please ensure you work on the milestones. They help us gauge if you're understanding what we are providing you with, and they also help us attend to your needs. Okay. So thank you once again for joining us, and see you in the next class. So if you have any queries, please reach out to your captain, and they'll be able to assist you. So thank you for joining, and have a good night and a great weekend ahead.